Okay, in this video, we're going to talk about two things. We're going to talk about converting, so from hex to binary, and we're going to talk about from binary to hex. Before getting into the mechanics of how to actually do that, why do we want to do that? So, why hex? Hex gives humans, us, a human readable representation of binary. And the reason that's useful is binary is really painful to write. If I wanted to write, let's say the number, I don't know, 3, right? And let's assume a 1 byte, and a byte is a sequence of 8 bits. So a byte is like the unit of information in computing. And if we wanted to represent the number 3, so number 3 equals, let's start from right to left, right? So we'll need 1, 0, or whoops, already made a mistake. So it'd be 1, 1, 0, 0, 0, 0, 0, 0. So that's 8 bits. And this, having the first bit and the second bit flipped on, this results in 3, right? Because the first bit is 1, second bit is 2. So 2 plus 1 equals 3. Now, all of that work just to represent the number 3. The good thing about so that's tedious. So how can we do better? Well, one thing we could do better is, what if we can, instead of writing out 8 digits, we can just use, let's say, 4 digits. Let's split this. Okay, so let me clear this now. Clear this sheet. And let's go back to the number 3. So it was, whoops. So it was 0, 0, 0, 0, 0, 0, 1, 1. What if we split this bit space in half, and we had a number of something, right, that represented these 4, another one that represented these 4 bits? Well, in hex, you can do that. Now, the only way to do that is if you have a number system or some kind of character system that can represent 16 characters. Why is that? Well, because 4 bits, 2 to the 4 is 16. So with 4 bits, you can represent up to 16 characters. And what are the 16 characters? There are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I'll continue on the right side. 10, 11, 12, 13, 14, 15. And you don't see 16 here because we start counting at 0. Now that's 16 characters. Now what base system, right? What kind of numbering system will we need in order to represent 16 characters or 4 bits in a base 2 system? What would we need in order to just use one character? Well, it would have to be a base 16 system, right? It would need to be a sort of new numbering system where a single character can represent any value in any of the 16 values. And that's how we arrive at hex, because in hex, you can use a single character to represent all 15. And I've written the 15 numbers in decimal, but in hex, what we have instead is 0, 1 to 9. These are all the same. And the differences are the numbers, in this case decimal, that have 2 digits. The difference in hex is you now have A, B, C, D, E, and F. Now, what does this mean for representing our original value of 3? Well, instead of writing all 8 values, right, all 8 bits, we can represent this as 0, and what is this? This is 3. So this gets reduced to just 2 characters, because by using a base 16 numbering system, we can use a single character, right, from 0 to F to represent any one of the 16 characters that are represented by 4 bits. And if we just combine these two, then we have a byte. Okay, so let's do more examples. Let's say you have a bit sequence, a single byte of, let's say, 0, 1, 0, 1, and then 0, 0, 0, 1. Now in binary, so this corresponds to 1. This corresponds to, what is this? This is, whoops, no, here. So this will correspond to, this is 2's place, and then this is the 8th place, right? So if we split it in half, and instead of looking at this in terms of base 2 system, if we were to convert this into hex, we split this in half into two sets of 4 bits, and this side will have a value of 1, and this side will have a value of 11 or 10, right? And this is decimal. Oops, let me make that clear. So this is if we convert to decimal. Now hex, we don't have 10, we have A, but we do have 1, because 0 to 9 is still the same as decimal. So in hex, we have this binary sequence will equal A1. So that's how you would convert. You split the byte sequence in half, then you figure out the value of each halves in isolation, and then you convert that to hex. So that's how you convert from. So actually, there's two. I want to highlight that there's actually 2 steps. At least I do in my head. So I take the bit sequence up here. So here we start here. We figure out what the total value is. I write it out in decimal. Then I map that to hex. Because I'm sure most of us, myself included, it's just easier to think in decimal. So there is an extra step of translation. Now going backwards from hex to binary, we just have to do this process in reverse. Figure out what is the value of A. Well, A is 10. Okay, so 10, how do I write 10 in binary, right? So we have, 10 is 2 plus 8. So we figure out, we'll flip on the second bit, we'll flip on the 4th bit. Now this can be a somewhat tedious process, but it's tedious process, but the trade-off is that when we do have values in hex, or when we are showing values in hex, they are easier to read and they take up less space. So hopefully this helps, and let me know if you have any questions.